Hello Nikhil, how are you?
Hey, hi Sushant, good afternoon. I'm good. Thank you. How are you?
I'm also doing good. Thank you for asking. Can you give me a brief introduction about yourself and your work experience?
Sure. Thanks a lot for asking. So, my name is Nikhil and I completed my graduation in 2021. I'm carrying a 4.5 year of experience in the field of machine learning and data science, where I have worked on mostly of the classical ML based projects, also on the some of the generative AI based projects, agentic based projects, and few of the MCP also, which are very booming field in the field of generative AI these days. So, if I talk about the tech stack which I have worked on, so mostly I'm working with the Python as a tech stack, and most of the time I use to Azure as a cloud platform, or sometime also with AWS and Google GCP also. If I give you a brief introduction about few of my projects, so one of my project was there, which is based on the classical ML based project was time series based time series based forecasting project. So basically, in that project, our requirement was that we need to predict the future date PCU count of the traffic light. So you must have seen that on the head of the traffic light, there is AUC maintained, automatic traffic controller. So basically, we need to predict the PCU count and automate the traffic lights. On top of that, I have carrying a three plus year of experience in the field of generative AI, where mostly I have worked on RAG pipeline, agentic workflow, multi-agent workflow, and all those stuffs. Please let me know if you want to go through any of the project. I can give you a brief introduction about those two.
Alright. Can you give me a brief introduction about your any of your generative AI projects?
Sounds good. So I'll give you a brief introduction about one of my project where we are working as a team of four people. We are working on as a staffing org people. So basically, we are a team of four, where the requirement of the client was they want to build something more exhaustive or enhanced than the Chat GPT at that time in the year of 2022. If I'm talking about more exhaustive, it means that earlier we have seen that ChatGPT was simply able to use that simple vanilla chat. It means that you can simply ask a question, it will provide you the answers. But it will not provide you any of the answers which are present in your environment or in your organization. So assume that if you have any PDF file and if you want to chat with those PDF files, it does not provide you functionality. On top of that, if you have your databases and you want to chat with the databases, you want to see the analysis, the trend of growth of your organization, anything such like business context, so you'll not be able to chat with those stuff over there. So we build all those stuff. We build a RAG pipeline to answer any of the query based on the PDF document or docx file along with the images too. On top of that, we have also generated the text to SQL so that if any business person comes up who have no idea about the SQL part or any databases, they can just simply hit their requirement, hit their questions like what are the sales of this company in year of 2021 or 2022. So we will generate a SQL query which will be executed on the any of the engine. We will fetch the data set for the relevant questions. We will execute this query, and then we will summarize the final answer and present in front of the answer. So on top of that, we have also given a functionality where a user can upload any of the PDF, and based on the size of the PDF, we have given a functionality to user to chat with those PDF in a given time frame, 2 to 3 minutes. So these were some of the functionality which we have developed for the client, in which we have the RAG pipeline, we have the text to SQL, we have agentic workflow.
Oh, sounds good. Sounds good. The format of this interview is I'll start with some basic Python examples, and then we can go deeper into traditional ML models like linear regression. Does that sound good?
Yeah, makes sense to
Yeah,
some.
yeah. So can you open any of your Python interpreter, anything that you're comfortable with?
Yeah, just allow me a time.
Hmm.
Would you like to share my screen?
Yes, please.
Is it visible to you?
Yes.
Will this Python compiler work?
Yeah, yeah. Anything that you're comfortable with. Yes.
Sure.
Okay. The first question is that you have a string. For example, let's say Mississippi. So you basically want the result as the count of each letter in that string, right? So for example, if it's a Mississippi, so M is there one time, I is there three times. So you just want the count of each letter in that string. And also please keep in mind while writing your code, just go through the process, like tell me whatever comes in your mind, what is your thought process, and explain what you're doing to me. Yeah.
So the expected output which you are telling is like count of each letter m should equals to one,
Mm-hmm.
something like this manner.
Mm-hmm.
Am I correct?
Yes. Yeah.
Sure. So I'll just thinking out loud. I can create a for loop which can iterate through each of the letter one by one. I'll store those letter into a dictionary. In the key, the letter will be there, and in the value, the count of letter will be there. At each time when I will encounter a new character, I will add it to the key value and assign it to value one. If the same letter is present in the dictionary, I will just increase the counter with one.
Mm-hmm. Okay.
Hope so I'm thinking the same page.
Yeah. Yeah. Sounds good. Yeah.
Let me try it again.
Mm-hmm. So, Nikhil, don't you think there is a small flaw in the logic?
Um, yeah, just allow me 2 minutes. Oh, sorry.
Mm-hmm.
If I encounter basically for IA, if I encounter I equals to one, encounter if okay, okay. Make sense?
Mm-hmm. Yeah. 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 This looks good. Okay. Yeah, we can move on to the second question. So, Nikhil, do you know what a palindrome is?
It means that those strings
Mm-hmm.
which start and end with the same. So it means that if we divorce it, it makes the same words. Am I
Okay.
correct?
Yeah. Yeah. So, can you write a function to figure out whether two given strings are a palindrome or not?
So basically, you want to write a code where to find out uh, with a given string is same palindrome or not. Am I correct?
Yes. Yeah.
So basically what I'm doing over here, I'm iterating this loop
Mm-hmm.
from zero to the length of word because I want to check it from very starting to the end of the letter. I'll check with the first letter. I will try to match it with the last letter
Okay.
and check it each and every time. If the complete for loop does not find every time it may be able to match it, we are good to go. If it anywhere it will not able to match it, I'll break that loop and I'll return it as a false and uh, then this particular string will not be a palindrome. Does that
Okay.
make sense?
Mm-hmm. Okay. Yeah.
I, word of I, plus 2, minus 1, minus 1, I, this, this, for you, that will make sense. So, yes.
Okay. Can you try with a word called such as madam? Okay.
Is it correct?
Yeah. Yeah. Sounds good. Okay. Yeah. Okay. Yeah. We can move on to the theoretical questions regarding linear regression now.
Sure,
Yeah. Yeah.
sure.
You can close the. Yeah. You can stop sharing. Okay. Yeah, let's start with the first question. So, what is linear regression and how does it work?
So basically, linear regression is a machine learning based a simple model which is try to predict the regression type values in the based on the given features. So it means that assume that there are two or three features given, and you want to predict any of the value based on that. So what this model does, it's try to create a best fit line in a particular space. It can be a two space, three space, or multiple space too, and find out based on that line. It will try to predict the value based on the given input. So the equation for this linear regression model is y is equals to ax plus by plus c, where a and b are the coefficient, x and y are the features. So assume that they are two features. Take example of a house price prediction. So number of rooms is the X, one of the features. Total carpet area is the another features. Whereas we are tuning that model with the parameter A and B, and where C is the bias term.
Okay. Okay. Sounds good. So, what is the difference between a simple linear regression and multiple linear regression?
So, if I talk about the difference between simple linear regression and multiple linear regression, in a case of a simple linear regression, we have one independent variable and one dependent variable. If I am talking about dependent variable, it means that it's a target variable. Target variable means that the column which we want to predict. And whereas one independent variable means that one of the feature which we are using to predict the particular dependent variable. Giving an example, so assume that given CGPA, you want to predict the package acquired by a student. So this is an example of simple linear regression.
Okay.
Going ahead for a multiple linear regression, in spite of a one feature, there can be a multiple feature over here, and there will be a one dependent column through which of which we are trying to find out. Giving an example of multiple linear regression, we can think of a house price prediction again, where we have multiple features. The number of rooms, carpet area, number of washrooms. So these are different features. Three features are there, but one dependent feature, which is the price of the house. So in this case, this is an example of multiple linear regression.
Okay, sounds good. Yeah, so earlier you mentioned the formula for linear regression, right? AB. So how do you interpret the coefficients and the intercept?
So if I talk about the coefficient and the intercept, so let's go a little bit in mathematical intuition. So basically, if you're saying that y is equals to ax plus by plus c, where uh, a and x is the variables, and x and y are the variables, a and b are the coefficient. Coefficient means that by tuning the coefficient or by changing the coefficient, we are changing how much the particular features are giving weightage to the model or giving importance to the model. So assume that we are increasing the value of a. A is the coefficient and x is the feature. So x is the number of room. So as we increase the number of room, the price of the house can increase. So if we increase the value of A, it means that if we increase the coefficient of A, it giving the weightage of the model. In the same way, the B will increase or decrease by increasing or decreasing the value of B, it will increase or decrease the weightage of B. Whereas C is the bias term, it means that when we are just trying to see that if all those features are zero, what should be the values for the given input.
Okay, okay, sounds good. Yeah, so the next question is what are the assumptions that we take in linear regression?
Yeah. So basically, there are five assumptions which we usually take in the case of a linear regression. The very first assumption, as we know that this is a case of a linear regression, the first assumption is that data should be a linear or sort of linear. So because we try to fit in the simple regression line over here, so we assume that the data should be a sort of linear data set.
Okay.
The other next assumption is that there should not be a case of a multicollinearity. Multicollinearity means that so if two features are not should be not should be collinear in the same manner to the dependent variable. So that's called the multicollinearity. It should not be there in our model. The third assumption which we take is that residuals should be normally distributed. It should be generating if we generate a graph of residual, it should generate a normal distribution on the plot. The next assumption is that the homoscedasticity. Homoscedasticity means that the residual should be of same spread. It should not be vary. Fifth assumption is that residual should not form any type of patterns.
Okay, okay, sounds good. So what is the cost function in linear regression and how do we optimize it?
So basically, cost function is the summation of all the loss function. So loss function is that. So while tuning the our any of the model, we first try to predict the value. Never the go in the very first iteration, we got the expected values. So basically, the difference between the expected value and the current value is called the loss function, and the accumulation of all those loss function is called the cost function. The what was the next question? Could you please repeat it once?
How do you optimize this cost
So
function?
yeah. So basically, to optimize the cost function, we use a method called gradient descent. In a case of a gradient descent, what we do is that we find out the cost function. Now, while going the back propagation, we update our weights based on the given law cost function. So this process keep on iterating again and again till the time we achieve the minima of our model in the gradient descent. So at each time we also have a value of a active 0.1 value as a weightage of the model so that it will not reach to a particular minima at a single one or two iteration. So we will go in a very slower manner so that it can reach the minima after a multiple iteration of time.
Okay, okay, sounds good. So earlier you mentioned that there should be no multicollinearity. So how do you find out if the data is multicollinear or not?
So there are the multiple ways to find out whether the does not have a the given data set does not have a multi-collinearity. The one very basic way is that we can discuss with our business persons who have this context, or take the business context to find out whether the given any of the feature contain the multi-collinearity or not. The next very technique is that we can generate a heat map, and through that we can find out that whether the any other column does contain the multicolority or not. The next very technique to find out the multicolority is that the VIF. So if the value of VIF, data should we have the multicolority. So the VIF should be less than 5. So these are few of the methods through which we can find out the multicolority in our data set.
Okay, sounds good. So, what evaluation metrics would you use to evaluate your linear regression model?
So there are multiple ways to evaluate our regression model. So basically, one of them is the RMSE, another is the mean square method. So these are different metrics through which we can evaluate our model. So if I talk about MSE, mean squared error. So what we are doing over here, we are squaring the error, doing the summation and finding out the mean so that we can find out the average error which our model is doing. So in this case, we are giving the high, penalizing the model doubles the error which it's made. To mitigate these things, what we do is that we use the RMSE. RMSE is the same thing. We just applying the root over square root of the MSE so that we remove the squaring the error. We just find out the simple error terms. So these are techniques to find out the accuracy of our model.
Okay, sounds good. What is R2 score and adjusted R2 score?
Yeah. So basically, if I talk about R2 score and adjusted R2 score, so R2 score is a matrix which will tell us how good our model is with comparison to a very basic model. So basically, it means that assume that without any iteration, without any data exploration, without anything, we just I fit a simple, very simple model. Assume that it can be a mean. So in that case, what the accuracy is, and now after doing all those iteration, all those mathematical calculation and data exploration, I applied a final model after doing all those parameters. How good our model is performing? The comparison between both two models and trying to find out the ratio between how these models are working. So this is the R2 score. Adjusted R2 score means that uh, if we increase the features, how the value of adjust R2 score is increasing. So to mitigate, even though if the feature is not too important. So to mitigate that issue, we use the adjusted R2 score.
Okay, sounds good. So, what is lasso and ridge regression?
Yeah. So basically, these are some of the regularization techniques which are used to tune our model when our model is either overfitting or underfitting or those cases when model is not performing as per our expectation. So in the case of a lasso regression, we use at that time when we want the features to be synced to a zero or we just want the features to be removed from our model if it not contributing well while predicting the final dependent value. So we use the lasso regression. In the case of a lasso regression, we use the lambda times modulus of slopes. Whereas in the case of a ridge regression is also called the L2 regression. So in that case, we don't want to make the coefficient to zero. We want to keep those coefficient, but it will the importance of those coefficient will become very less. So basically, ridge regressions are used when we have a case of a multicollinearity, and lasso regression are used when we want to do the feature selections.
Okay, great. Sounds good. Yeah, so you mentioned overfitting and underfitting. So, can you briefly explain what underfitting is, what overfitting is, and how can you mitigate those?
So basically, if I talk about the overfitting and underfitting is the case when our model is performing well. It's when while the training dataset, but while its production dataset or to the new dataset, it not able to perform the very best. So those cases is called the overfitting. So we can remove those overfitting by using the cross validation technique, by increasing more data, by increasing regularization technique as we discussed the lasso and the race, removing irrelevant features. So these are the ways to remove the overfitting. Now, if you come to another topic, the underfitting. Underfitting is the case when our model is not performing very well in the case while we are training the data set. So, though that was the case of underfitting. So, if I talk about how to mitigate the underfitting case, we can increase more feature to our data set. We can use the polynomial terms in our data set. We can decrease the regularization strengths. So these are the ways to mitigate the underfitting.
Okay. Yeah, sounds good. Yeah, I think that is those are all the questions from my side. Thank you for joining this call, and yeah, good luck.
Yeah, thanks, Susan. Thanks a lot for your time. Have a great day. Bye bye.
Bye.